Biology lesson 2, chemical and cellular basis. Chemical and cellular basis of life. Initially, we have to talk about chemical basis. Chemical basis. Under the chemical basis part, we have to talk about six main topics. First one is elements, compounds. Third one, nucleotides. Nucleotides and enzymes, photosynthesis. 6, cellular respiration. You know, elements are bound together by bonds and make compounds. Okay? Elements are bound together by bonds and make compounds. Initially, we are talking about elements. So, in your tube, in first page, there is a space here. So, fill this space with me. Elements. What are the elements? What are the examples? What do you use? All the elements in the periodic table. Okay. Here you have to know about these main 3 points. Under the element part, number of elements can be found on the Earth surface. This 92. Okay. This 92. 92. And number of elements which are contribute to make the living bodies in plants and in humans. Okay. In plants it is 17, in humans it is 25. No? Yes, it is 25. As a percentage, 20 to 25% of 92 elements are involved in making of the body masses. And what about the living matter? Living matter, 96% of living matter and the remaining 4%. 96% of living matter contains carbon, hydrogen and CHO and N. These main 4 elements. In other remaining 4% majority contain calcium, magnesium, calcium, phosphorus, potassium and sulfur. Other than that, we can see sodium, chlorine, magnesium, boron, cobalt, copper, fluorine, iron and iodine. Okay, so that's all about the elements, and then we will move on to the compound parts. Okay. Compounds. You have categorized compounds. First one, organic compounds. Simply we can say carbon containing compounds, organic compounds and inorganic compounds. Okay. Inorganic compounds, no carbon. Simply we can say no carbon. Organic compounds again can be divided into 2. What are the 4 major or main organic compounds? 4 major or main organic compounds we are talking about: carbohydrates, proteins, lipids, nucleic acids. Okay. Other or minor organic compounds, we consider hormones and vitamins as organic compounds, but they are not major or main organic compounds. The main inorganic compound is water. Molecular formula is H2O. Okay. Other than that, we can see inorganic salts, and some gases. Even carbon is included. Some compounds are never considered as organic compounds. They are actually carbon-containing inorganic compounds like carbon dioxide, carbon monoxide, bicarbonate ions. Okay, so some gases means carbon dioxide. Sorry, nitrogen, hydrogen, like gases. Carbon dioxide and carbon monoxide are also inorganic compounds. Even they have carbon. Okay, the simple explanation is it is not a hydrocarbon. It is not a hydrocarbon. Okay, and initially we are talking about water. So if you are not water. Water is the vital inorganic molecule. Life could not exist on this planet without water. Under the topic water, okay, please write this one. Water is the most abundant compound on the Earth surface. Most abundant compound on the Earth's surface is water. Water is an inorganic compound. Write this one, and also you can write this. These are MCQ points actually. That is the most abundant organic compound. Most abundant organic compound, carbohydrates. Okay, and the most abundant carbohydrate in the world is cellulose. Cellulose. Okay, you have to write this one. Here, in a note, water is a vital inorganic molecule. Life could not exist on this planet without water. If they ask about the importance or functions of water, you have to mention these 2 points. Vital chemical constituent of living cell, provides a biological medium for all organisms. If they ask about the properties of water, you have to mention these 4. Cohesive behavior, ability to moderate temperature, expansion upon freezing, versatility as a solvent. You have to mention these 4 properties. Okay, most of above properties are based on the chemical structure of water molecule. Water. Molecular formula is H2O. Here you can see H2O ratio is 2 to 1. Okay, H2O ratio is 2 to 1. And what about the chemical structure? Oxygen. Oxygen is the central atom. 2 hydrogen atoms are bound to central oxygen by single bonds. You know, when we are drawing the Lewis structure of some molecule, we have to consider the octet rule and especially about the central atom. Oxygen is 6 group element. That means 6 electrons should be around oxygen. 1 and 2, the remaining 4 are appeared as lone pairs. Therefore, we can see 2 lone pair of electrons around oxygen. So what about the geometry? 1, so you can see repulsive groups of Western groups 1, 2, 3 and 4. 4 Western groups means around oxygen. We can see the tetrahedral geometry. Okay, tetrahedral geometry. So what is the bond angle? In a normal tetrahedral molecule, 109. 109.5. Even it has a tetrahedral geometry. Due to the presence of these 2 lone pair of electrons, the shape of the H2O molecule differs from the tetrahedral shape because actually due to the high repulsion. Okay, high repulsion between these 2 lone pairs and between the lone pairs and bonding electrons. Therefore, this is the 109.5 gap, oxygen and actually the angle is close to each other due to the high repulsion of these two lone pairs. Therefore, in water molecule, it is 104.5. Okay. So, geometry is tetrahedral, but the shape is angular shape. This is the chemical structure of water molecule. Okay. What is the importance? What are the importance of functions of water? Biochemical constituent of living cell provides a biological medium for all organisms. Most of above properties are based on the chemical structure of water molecule. Physical and chemical properties of water molecule provide the ability to render the vitamin D. Water is a small, whole and angular molecule. Angular molecule, is it okay? Is it okay for you? Angular molecule, its shape is angular, even its shape should tetrahedral due to the presence of two lone pair of electrons. Its shape differs from tetrahedral to angular shape. And also water is a polar molecule. Polar molecule means to consider as a polar molecule, the particular molecule charges should be separated. Charges should be separated, or we can see unequal charge distribution. Unequal charge distribution. Okay, you know, think about this bond. Okay, we represent this bond in a single line. So actually, two electrons should be there. So oxygen is an electronegative atom, hydrogen is an electropositive atom. So these two electrons are attracted by this central oxygen because oxygen is an electronegative atom. If electrons are attractive, means oxygen takes delta minus value. Delta means small value. Hydrogen tends to pull electrons towards the oxygen, that means delta plus. Okay. So you can see unequal charges distribution. We can see unequal charges distribution. Charges are separated. This behavior is known as polarity. So water is a polar molecule. Okay. And what about the intermolecular interaction? What about the intermolecular interaction between water and another water molecule? If this is a water molecule, you know delta minus, delta plus, delta plus. Okay. This is another water molecule, delta minus, delta plus, and delta plus. Okay. Between these two, you know hydrogen bonds. Hydrogen bonds. To make hydrogen bonds, hydrogen should be bound with an electronegative atoms. There are three electronegative atoms we are talking about: nitrogen and chlorine, oxygen, nitrogen and chlorine. Here, OH. Here, intermolecular interaction is a hydrogen bond, O and H. Okay, this hydrogen bonds. Okay. This is the intermolecular interaction between a water molecule and another water molecule. Okay. Polarity is an uneven charge distribution with the molecule. In a water molecule, oxygen atom is slightly negative and hydrogen atom is slightly positive. Weak attractions between the slightly polar hydrogen atom of one water molecule and the slightly polar oxygen atom of adjacent molecule are known as hydrogen bonds. These hydrogen bonds play a major role in maintaining all properties of water. So what are the properties? Cohesive behavior, ability to moderate temperature, expansion upon freezing, and versatility as a solvent. The properties of water arise due to attractions of different water molecules. When the water is in liquid form, its hydrogen bonds are very fragile. Hydrogen bonds can form, break, and reform. Form, break, and reform. So what are the properties of water? What are the major properties of water? First one is cohesive behavior. For all properties of water, hydrogen bonds are highly involved. Okay. Hydrogen bond is a type of intermolecular interaction between one molecule with another molecule. That is the intermolecular interaction. So here the intermolecular interaction type is hydrogen bond. There are two terms, cohesion and adhesion. Cohesion and adhesion. Okay, imagine this is a water molecule. Okay, this is a water molecule. Intermolecular interaction, hydrogen bond. Okay, intermolecular hydrogen bonds are occurred between one water molecule with another water molecule. This intermolecular interaction is cohesion. And water can also make intermolecular interaction or hydrogen bonds with another molecules, especially hydrophilic molecules. Okay. Hydrophilic means water love. They like water. Water love molecules. So this intermolecular interaction we known as adhesion. Adhesion. Okay. Attraction between water molecules due to hydrogen bonding is known as cohesion. Attraction between water molecules and other substances are known as adhesion. Both the above properties of water allow it to act as a transport medium. So, transport medium. Can you remember or do you know about the vascular system in plants? Vascular tissues. Two types of vascular tissues can be found in plants. First one is vascular tissues. Okay. First one is xylem. Second one is phloem. Okay. Actually, these tissues are a tube-like structure. Okay, tube-like structure. Inside these tubes, materials are transported. If this is the xylem tissue, if this is the phloem tissue in a plant, okay, in a plant, water and minerals are transported via the xylem tissue. That means via this xylem tissue, directly water is transported, mineral ions are dissolved in water. Okay. In the phloem, mainly sucrose is transported as a solution. Sucrose is solution. Okay, sucrose is transported. Sucrose solution in chemistry, you know, solution is a solution. Solution is a mixture. This mixture is composed of two components, solute and solvent. Okay. Here, solute is sucrose, solvent is water. That means sucrose is dissolved in water. So here, in the phloem tissue, sucrose is transported as a sucrose solution. That means it's an aqueous solution. So water is there. Water is also there. Here directly water is there. Mainly sucrose solution. Okay. You know these water and minerals are absorbed by plant roots, and they have to transport it in these parts in the plant against the gravity. Okay, gravity force in this direction. These materials are transported in upward movement, that means against the gravity. So how the materials are transported against the gravity? How they are transported? Actually, the hydrogen bonds. adhesion and cohesion are involved. Okay, think this is a pyramid enlarging. The whole tube is the xylem tissue. Okay, whole tube is a xylem tissue. This is a water molecule and this is a water molecule, water molecule, water molecule. So intermolecular interaction, intermolecular hydrogen bonds are occur between these two water molecules. This is a hydrogen bond. Okay, this bond is cohesion. And hydrogen can make interaction with actually the xylem wall. Okay, xylem wall is mainly composed of cellulose. So this intermolecular interaction we call as cohesion or adhesion. This intermolecular interaction we call as adhesion. Okay, adhesion. Due to these two, xylem wall is composed of mainly cellulose. Cellulose is a hydrophilic compound. Okay. Attraction between water molecules due to hydrogen bonding is known as cohesion. Attraction between water molecules and other substances are known as adhesion, other hydrophilic substances. Both the above properties of water allow it to act as a transport medium. Xylem directly water with mineralized phloem tissue, sucrose. Due to the cohesion between water molecules, water and dissolved substances such as minerals and nutrients transport to vascular tissues, xylem and phloem against the gravity.